Hello everyone and welcome back to my series on CSEC Math Paper 2 Worked Solutions. So I'm on January 2025, question 9 part B, which is on trigonometry, specifically bearings. So we have a diagram showing two ports E and G on level ground 245 kilometers apart. The bearing of E from G is 302 degrees. A ship is anchored at F some distance away from G on a bearing of 228 degrees. Angle EFG is 52 degrees. So for part 1, part A, we need to insert the angle 228 degrees, the bearing of F from G. Right, so bearings are measured clockwise from north from the reference point. And since we're measuring the angle from G, we already have the north line drawn at G. So clockwise from that north line up to the line that joins G to F will be that angle in blue, which is 228 degrees. So that's the bearing. All right. So that's one mark. For another mark, part B, we have to determine the value of angle FEG. FEG, so that's this angle up here. So before I find that angle, there's another piece of information they gave us in the question, which is the bearing of E from G, which is 302 degrees. So let's insert that on the diagram. So again, the bearing is measured from G, so clockwise from north, going this way up to the line that joins G to E, because it's the bearing of E from G. So that entire angle in green is 302 degrees. So since both these bearings start from the north line, one goes up to FG, one goes up to EG. The difference between those two angles will be this angle here between EG and FG. So if I subtract 302 minus 228, I will get 74 degrees. So angle G is 74 degrees. So if I add now 74 plus 52, that's 126, and I take that away from 180, I will get angle FEG to be 54 degrees. Okay, so let's write down the working for that. So first we found angle G, which was 302 minus 228 degrees. That gave us 74 degrees. Then we found angle FEG, which is 180 minus 74 plus 52, which is 180 minus 126, giving us 54 degrees. Okay, so let's go on to part 2 of the question. For 2 marks, we want to calculate GF, the distance the ship is from port G. So instead of having to scroll back up to the diagram, I'm going to redraw it here. Okay, so we're going to put in the angles. So we found this was 54 degrees. We have 74 degrees. And this is 52 degrees. And the distance EG was 245 kilometers. Okay, so we want to find the distance GF. So let's look at what we have in the diagram. So the distance GF is opposite angle E. So that will be, if I label that side, it will be common E. And then I also have the side that is opposite angle F. So I'm going to label that common F. So since I want to find the side that is opposite this angle, and I have the side that is opposite this angle, it means I need to use the sine rule. So I would have E over sine of angle E is equal to F over sine of angle F. So let's substitute. So small e, which is our unknown, GF over sine of angle E, which is 54 degrees, is equal to small f, which is 245, over sine of angle F, which is 52 degrees. So if I cross multiply like that, I have GF times sine 52 degrees is equal to 245 by sine of 54 degrees. So therefore GF is equal to 245 sine 54 over sine 52 degrees. And if I work that out to my calculator, 245 sine 54 equals, and then I take that answer and divide it by sine of 52, I will get GF to be 251.5 kilometers. Okay, so that's 2 marks. So let's go on to the last part, part 3. For 2 marks and 2 and 1 3 marks, part A, indicate the point H on the line EF such that GH is the shortest distance from G to EF. And part B, determine the distance GH. So again, I'm going to redraw the diagram because we already have so many things on the previous diagram. Okay, so I'm gonna put in the 54-degree angle. I'll put in the 52-degree angle, but I'm not gonna put in the 74-degree angle. You'll see why just now. So just gonna fix this here. And I apologize for my stylus. Okay, so GH is the shortest distance from G to EF. We know the shortest distance between any 2 points is a straight line. So if I were to draw a straight line straight across from G to meet EF, this point will be H. So GH is actually a horizontal line. So to find that distance, let's go back to the bearing that we had from the beginning, the bearing of F from G. So this was our north line, and the bearing was this angle here, which was 228. Now I'm going to extend the north line down. So you see now that if I break up the angle, I have this piece, which is 180, and then the remainder, which is 228 minus 180, is 48. So this little angle here is 48 degrees. Now, we just drew this line GH, right, which is horizontal, and then I have the north line, which is vertical. So this forms a little right angle right here. Right? So therefore, if I subtract 48 from 90, I will get 42 degrees. So I'm going to put it in another color. So this angle here is 42 degrees. Okay, so let's focus on this triangle, right? GHF. Okay, so remember I already found GF, that was 251.5 kilometers, and I want to find GH, Now the problem is I don't have the angle opposite this side, but I can now that I have this angle. So if I add 42 and 52, that's 94, and then 180 minus 94 will give this angle in this corner here to be 86 degrees. So now let's label our triangle. So in this case, the 251.5 kilometers, because it's opposite angle H now, that will be small h. And this side, GH, will become small f because it's opposite angle F. So using the sine rule again now, I would have F over sine angle F is equal to H over sine angle H. And let's substitute F, small f, which is the distance GH, which is what we want to find, over sine of angle F, which is 52 degrees, is equal to H, small h, which is GF, 251.5 kilometers, over sine of angle H, which is 86 degrees. Okay, so again, cross multiplying, so GH times sine 86 degrees is equal to 251.5 sine 52 degrees. So therefore, GH is equal to 251.5 sine 52 over sine 86. So using my calculator, 251.5 by sine 52, and then take that answer and divide by sine 86, and I will get 198.66, so 0.7 kilometers as the distance GH, right? And that is worth 2 marks.